Hello and welcome to My Maths Week 1 Video 1. In this video we'll be covering sequences, a review of the basics. So a bit of an introduction, you may refer to me as epsilon, as in the Greek letter epsilon. That's what the spelling looks like. So I'll be taking you through the syllabus for this year. Okay, so let's begin. We'll start off with just a recap of the few concepts that we know about sequences from earlier grades. So, a review. We start off with the two types of sequences that we've covered so far, which include the arithmetic sequence. Just separate these two. Doesn't look very straight. Just fix that. Okay, that's a bit better. And the quadratic sequence. So we have quadratic and arithmetic. So what separates these two types of sequences, or what's the difference between these two? So the way we can see the difference between these two types of sequences is to look at their individual properties. How do they behave? So if we look at the properties of an arithmetic sequence, let's look at an example of one, which can be, let's say, 3, 6, 9, 12, 15, and so on. So by looking at this arithmetic sequence, if we were to find the difference between the terms, we would see that that would give us 3 there, 3, another 3, and 3 repeatedly. So we see that the difference, or the first difference between the consecutive terms, is constant. So if we give more and more examples of arithmetic sequences, we see that this property is the same throughout all of them. Let's show an additional example. Let's say that we have a sequence. Let's change it up a bit this time. Let's make it a decreasing sequence. Let's say we have 4, 2, 0, -2, and so on. So in this case, if the sequence is arithmetic, we would expect that the difference between the terms should be constant. So if we were to find the difference, we would see that we have 2 minus 4, which is -2. We have 0 minus 2, which is still -2. We have -2 minus 0, obviously, -2. This pattern continues. So we see that there's a common trend amongst these arithmetic sequences, and that is the first difference is constant. Okay, so we see that for all arithmetic sequences, the first difference must be constant. Let's look at the properties of quadratic sequences. So let's extend this divider a bit. Okay, so for quadratic sequences, let's see what the properties are. Let's look at an example. So we have, let's say we have a sequence that looks like this. We have 2, 3, 5, 8, 11, and so on. Okay, so let's look at what the first difference is in this case. Okay, we get 3 minus 2, which is 1, 5 minus 3, which is 2, 8 minus 5, which is 3, 11 minus 8, which, realize that there's a mistake here. This should be a 12, please excuse that. Okay, so if that's a 12, then our difference here should be a 4. Okay, so in this case, we see obviously that the first difference is not constant. But if we were to go and find the difference between these numbers here, we would see something. We would see a pattern that begins to emerge. So we have 2 minus 1, which would be a 1, 3 minus 2, which is 1 again, and 4 minus 3, which is 1. So we see that in this case, the first differences are not constant. But if we were to find the differences between that set of differences, we see that we get something that is constant. Therefore, we can conclude that the second difference of a quadratic sequence is constant. So let's just conclude second difference is constant. Okay, these are the two basic properties of arithmetic and quadratic sequences. Once you know these properties, then you can solve any question that's based on arithmetic or quadratic sequences. Okay, it's just a matter of applying this knowledge. So let's move on to something that we also covered a bit earlier, which was finding the general term. The general term of a sequence. Okay, so you might be wondering, what does it mean exactly to find the general term of a sequence? Basically, a general term is a rule. It's a rule that allows us to find any term in the sequence. Okay, so let's say that we had some sequence that looks like this. Term 1, term 2, where these terms are just random numbers, arbitrary numbers. We have term 1, term 2, term 3, term 4, term 5, and so on up to some term number n. Let's just call it term n. So the general term is just a way of finding term n. In this case, we don't know what term n is. It could be term 5, term 100, term 57, whatever term number. So basically, we call that the general term. It's just any term in the sequence. We could have put Tn as the second one here, or we could have put it here or wherever. It's just any term in the sequence. So that's what it means when they say find an expression for the nth term. They just mean find a rule that allows us to find any term in the sequence. Okay? So in this case, looking at arithmetic sequences, for example, let's say that we had an arithmetic sequence and we want to look into the general term of an arithmetic sequence. So let's just take one from our previous example. Let's take this one here, 4, 2, 0, negative 2, so on. Okay, so this is an example of an arithmetic sequence. So in terms of the general term in this case, how would we go about finding it? Okay, first of all, we need to know what the general form of the general term is. I know that may sound a bit confusing, but when we say the general form, we mean something like this. Tn is equal to a plus n minus 1 d. This is the general form of the general term. So in this case, the reason why I say it's a general form is because any general term of an arithmetic sequence takes this basic shape. And what do I mean by that? I mean, if we have any arithmetic sequence, its general term can be written in this form. Let's say that it's 4 plus n minus 2 times some difference. Let's just say it's 2. So we know that if we were to write something like this would represent the general term of some arithmetic sequence. Okay. So in this case, we want to find the general term of this specific arithmetic sequence. All right. So the way we would do that is look at the general form. And the general form tells us that Tn will be equal to a plus n minus 1 times the difference. Remember that a is the first term, and d is obviously the difference, or first difference, since we're dealing with arithmetic sequences here. So let's do a bit of substitution. We'd find that Tn will be equal to a, which is the first term, that's 4, plus n minus 1 times the difference. We found the difference previously to be equal to negative 2. So we go and plug that in, negative 2. So if we were to simplify this, we would get 4. Let's write it like this, times negative 2n plus negative 1 times negative 2. So we're just distributing into the brackets. We get 4, negative 2 times n, it's just negative 2n, negative 1 times negative 2 plus 2. So we would get Tn is equal to minus 2n plus 6. Okay, so that would be the general term for this arithmetic sequence. Okay, so we move on to quadratic sequences. Okay, quadratic, this one is a bit more work. The process is a bit longer, but with quadratic sequences, let's take an example first of all. Let's take this one, 2, 3, 5, 8, 12. Let's say we have 2, 3, 5, 8, 12. So this is our quadratic sequence, right? In this case, finding the general term is a bit more complicated, but it's still not difficult. Okay, so first we need the general form. We need to know what shape the general term needs to look like. So that's Tn equals to an squared plus bn plus c. So we know that when we find the general term of this sequence, it'll look something like this. Okay, so basically we need to find a, b, and c. And the way we do that is we write it out. Let's write that out again. And we find the differences, first and second differences. So we see that that's 1, 2, 3, 4. We go and find the second differences, which are 1. So let me just move this a bit to make some space here on the side. So what we do now is we say, okay, this bottom row of numbers, just take the first one and say that that's equal to 2a. Then in this middle row of numbers, we take the first one and say that is equal to 3a plus b. Then in the top row of numbers, we take the first one and say that is equal to a plus b plus c. And the reason why we do this is a bit long to explain, but we'll come back to it later. For now, just keep in mind that it's a plus b plus c for the first, 3a plus b for the second, 2a for the third. So we can go and write this down properly. We have, starting from the bottom, let's start from the bottom because this is the easiest one to solve. Then we can move up. So we have 2a equals 1. This is easy to solve. We get a equals 1 over 2. Okay, move up. Get 3a plus b equals 1 again. We substitute the value of a, that's 3 times 1 over 2, plus b is equal to 1. So we get b is equal to negative 1 over 2. Okay? Then we get a plus b plus c equal to 2. We substitute again. That's 1 over 2 minus 1 over 2 plus c is equal to 2. Obviously, we get our answer to be c is equal to 2. Okay, so now we have our values for a, b, and c. We can now go and substitute into our general form. Remember that the general form looks like this. So we conclude that therefore Tn should be equal to 1 over 2n squared minus 1 over 2n plus 2. Okay, so that is the general term of that quadratic sequence. And I did promise you that we would go over and say why we choose these numbers here to be 2a, 3a plus b, a plus b plus c, and so on. Okay, let me just do as quick of an explanation as I can. We don't want to go into too much detail into this, but I think it might be useful for you to just know where this comes from. So we know that the general term of a quadratic sequence looks like this, right? an squared plus bn plus c. So that would mean that t1, the first term, if we were to just substitute 1 into n, we would get a times 1 squared, which is just a, plus b times 1, which is just b, then plus c. Okay? Then our second term, t2, would be equal to a times 2 squared. We're substituting 2 into n now. So we'll get a times 2 squared, which is 4a, plus 2 times b, which is just 2b, plus c. Okay? We get our third term to be equal to, we're substituting 3 into n now. So that would give us a times 3 squared, which is 9a, plus 3 times n, which is, or 3 times b, which is 3b, then plus c. Okay, if we continue this, we get t4 equals 16a plus 4b plus c. Get t5 equals 25a plus 5b plus c, and the pattern continues. Okay, so if we were to write these terms down, we get a plus b plus c as the first term, 4a plus 2b plus c is our second term, 9a plus 3b plus c as our third term, and 16a plus 4b plus c is our fourth term, and so on. So if we were to find the differences between these terms, okay, we would get 4a minus a, which is 3a, 2b minus b, which is just b, then c minus c, which is 0. Okay, so we would move on to the second one. 9a minus 4a, that's 5a, 3b minus 2b, that's b, then c minus c is 0. Okay, so we have 16a minus 9a, in this case, that's 7a. We have 4b minus 3b, which is b, c minus c, which is 0. So if we go ahead and find the second differences here, you'll see that a pattern is emerging. We have 5a minus 3a, that's 2a. Then b minus b, which is 0, okay? We have 7a minus 5a, which is 2a. Then b minus b, which is 0. So you'll notice something. We have 2a here, we have 3a plus b, and we have a plus b plus c. So from this we can conclude that for any quadratic sequence, the first number at the bottom here, let me just change colors there to make that a bit more clear. First number here at the bottom should be equal to 2a. And the first number here in the second row should be equal to 3a plus b. And the first number in the top row should be equal to a plus b plus c, in the same way that it looks here. Okay? So that's where these rules come from. Okay, so that's how you find the general term of an arithmetic or quadratic sequence. So from these basic properties, you can solve basically any question that involves arithmetic or quadratic sequence. You just apply these properties. Okay, so that brings us to the end of our first video. Our second video will be coming out soon. We'll be moving on to geometric sequences, which are new in the grade 12 syllabus. We haven't covered them in earlier grades, so we can look forward to that, and we will see you soon.